here. So this is omega becomes alpha t. So that's how it is. Now, same thing here. N is like this, Ng is like this. So N is equal to Ng. And then what is the net pseudo force like this? So what should be the direction of frictional force like this? Be careful, neither tangential nor this, resultant of those two making certain angle. Okay? And therefore, your FL is mu n is mu mg is, what are you putting? This square plus this square, m into r square alpha square plus all this square, r square alpha 4 t4. Because these two are perpendicular, so the resultant force magnitude is sum of the squares of the two. So you got it like this, and well, strike it off. So you get mu square g square is r square alpha square plus r square. This is how it is. And now maybe I can write mu square g square minus r square alpha square by r square alpha raised to 4 t raised to 4 r. So 1/4 of all this, that is the time at which it begins to slip. Hell of a difference between these two cases. We have to be very, very careful. And if they ask you at what angle does the friction act, let us take it as theta. So tan theta is this divided by this. And this is m r alpha. The other one is m r square m r alpha. M r alpha, omega is alpha t, m r omega square, m r alpha t. Yeah, there is no square here, right? So that's what I'm wondering. It should be non-dimensional, remember. So, okay, I think it has gone down. I'll put it here for you separately. Tan theta is mr alpha by m r alpha square t square. So you have 1 by alpha t square. With the radius, this is the angle it makes, the frictional force. If at all they ask, that's how you have to give it. Is this clear to you? Right. Now if you recall, I gave you a case where there is a rod, you have kept a cylinder, hollow cylinder, you have inserted into it with a mass m, and the whole thing is rotating with alpha at t is equal to 0. G is 0, no gravity is present. Remember, we did it for Fs. So what happens, as I describe it again, this is the body and it tends to move like this. So normal force is into the board. Mg is 0, it doesn't act. So N, and then it is going with a R alpha. So what is the pseudo force? M R alpha. A inside, MA outside. So N is equal to M R alpha. And what provides the required centripetal force? The body just about to move. FL is equal to mu N. But what is FL? M R omega square. M R omega is alpha t. Therefore, M R alpha square t square. Now N is equal to M R alpha. Mu M R alpha. M gets cancelled, R gets cancelled. So T is equal to. See how beautiful this concept is? The time is mu all by alpha under root. This will start slipping. So, it all depends. They ask time, you give time. If they want to know what is omega at that time, you give it omega is alpha. Whichever way you want, you can do that. Okay? This case also we discussed, but I am now looking at the minimum required force for the body to move, or minimum required acceleration, or the minimum time at which it starts slipping. Okay? Yeah, I think after this probably I'll look at horizontal, vertical surface, and F. I said this is about to slip. Therefore, you are getting a limiting frictional force. Yeah. How do you write? FL mu N is equal to mg. Your F must be at least mg by mu. Now what is this F? This is the minimum force for the body not to slip. Minimum F for body not to slip. Otherwise it will slip down. So, for not slipping, F must be greater than or equal to mg by mu. That's how you have to have. Supposing I am taking a surface which is accelerating with A, and as I said, you may take pseudo force N, Fl, mg. The more the acceleration here, the more stable the body would be. For that body not to slip, for body not to slip, for body not to slip, what do you get? Not to slip means your Fl is equal to mg, Fl is mu n, is mu ma, so A equal to g by mu. So this is A minimum, and A must be greater than or equal to A minimum equal to g by mu. What for? For the body not to slip, minimum acceleration is g by mu. If you go with more, it will never slip. This is about the vertical case. Okay? Now, we also took a case of cylinder. recall, here is a body and this is R, and this is N. N is centripetal force, mr omega square, and this is mg, this is FL. So you have FL is mu N is mu mr omega square is mg, mm. Omega is G by R mu. So just about to slip. So if you have this, if mu, suppose omega is less than this, then the body will slip down. Remember. Okay? So you have, this is the minimum omega for the body not to slip. Okay? Now, next, instead of this, if I take a cone, with a semi-vertex angle alpha, this is R, this is the body, this is small r, this is H, L. The standard things you know very well. If I take it as, say, at a distance y, tan alpha is R by H or small r by y. Similarly, sin alpha is R by L or small r by root of R square plus, because this is y, this is R square plus y square. Okay? Whichever way you want, you can do it. General things. But this is your normal force. Now here, we already discussed, if it rotates slowly, there is a tendency for the body to move down. If you rotate it very fast, there is a tendency for the body to slip up. Now there are two possibilities. When the surface is inclined, it is always dangerous, remember. Is it talking of minimum? Is it talking of maximum? You have to see. Now you have to have a minimum omega for the body not to slide down. And you have to have a maximum omega for which the body cannot slide up. So there is a range of omega values for which this body would be stationary. What is that range? I hope you have understood my point. Omega minimum for body not to slide down. Omega max for the body not to slide up. What is a range for which body will not slip? Between omega. So omega must be greater than or equal to omega minimum. So we need to find out these two values. This is a very ticklish aspect of the friction. Various cases, various places you come across this. I think I want you to be careful while drawing even the FVD. So, first of all, I draw this case, N. Tend to slide down, just that sliding is arrested. So, FL. No. MG. Okay? Right. So what is the, of course, the semi-vertex angle is alpha. So here, this is bound to be alpha, N cos alpha, and sin alpha. If this is alpha, this is also alpha. So this will be FL cos alpha, FL sin alpha. I purposely told you about a similar diagram in one of my earlier videos. You could see that why I should take like this. Because the acceleration is in this direction, so I want to take it. That is one way. Yeah, if you want to take like this, feel free to take. But take component of acceleration in that. Then you have one acceleration like this, another like this. And what is that mr omega square? Mr omega square cos alpha in this direction, mr omega square sin alpha in this direction. Then take components along this, and equate. Fine, you will get the same answer. And I want you to try on your own. Okay? Now what is the centripetal force here? What is the centripetal force? N cos alpha minus FL sin alpha. M R omega square. Okay? We will call it as omega minimum. Now, you see, supposing sorry friends, the other one is, suppose if it rotates very fast, there is a tendency for the body to slip up, then FL will be down. I'll try to put that here. FL and G. Now, this is N cos alpha. This is FL sin alpha. So how do you write the centripetal force there? Simultaneously, when I'm writing it, you don't have any issue at all. And then what about this? This is done. What about this? This to N sin alpha plus FL cos alpha is equal to Ng. These two. Here, this is FL cos alpha and this is N sin alpha. N sin alpha minus FL cos alpha is equal to Ng. Look at the difference. Simultaneously, I am getting for minimum for the body not to slip down, maximum for the body not to slip up. So they will get a range of values. And now the rest, of course, is a simple mathematical jugglery. Very easily we can do it. Now, if I divide and write FL as mu n, n is common, it gets cancelled. And I divide the numerator and denominator with cos alpha. So that no change in the, so it becomes 1 minus, what do you get? Mu tan alpha, mu n gets cancelled, tan alpha. Here, tan alpha plus mu, this is equal to G by R. I am bringing this. This is the minimum. Now, what do you get here? Same exercise. M gets cancelled, mu n gets cancelled, divide with cos alpha numerator, denominator. Then what are you getting? G by R. This is very interesting. Very, very interesting. You can't give a single value here for which, as I said, is small r you can write in terms of the data that they give. It could be anything, it doesn't matter, but you can do that. Okay? Now, if I write this, now, first I'll write this. Wow, sorry.